First one says the area of a circle is 60 pi. What is the radius? Can someone tell me how to set this up? Labib.
60 pi
equals pi r squared. Perfect. Then my next step would be to basically divide both sides by pi so I can eliminate that pi. And then we'll have r squared equals 60. I take the square root of both sides. I come up with r equals the square root of 60. And I'm done, right? No, I'm not done. What do we have to do?
Simplify.
I have to simplify because someone tell me what the simplified version of square root of 60 is. Yeah.
2 squared root of 15.
It'd be 2 square root of 15 because you can rewrite this as 4 times 15, which would equal 2 square root of the old 15. All right, the next one looks like everyone got it correct. Let's just go through it. We have a circle. We have a central angle of 75 degrees. So let's go ahead and draw that. This is 75 degrees. The important thing about a central angle being 75 degrees is that the arc degree is going to also be 75 degrees. Now it says find the measure of the arc. Measure of the arc tells me I'm looking for something with the circumference. It is length of a line. So the circumference of this entire circle was set with a radius of 12 would be pi 2 pi r, which is going to be 2 pi 12. Well, that would be our entire, it'd be our entire circumference. I don't want the entire circumference. I just want that little bit. So we would then do 75 divided by 360. And that should come out to that 5 pi, right? Yep. So the correct answer was 5 pi. And I should really have 5 pi centimeters because it was centimeters. All right, questions from the homework? Yes?
11. I
The
got
triangle?
total area and I got the hold on.
Holden.
Yeah, I got the total area and then from there I didn't know what to do.
So you got the total area of the triangle, right?
Yeah.
Okay, so we need triangle minus circle, correct?
Mm-hmm.
So we have so we have an equilateral triangle. It has a circle inside of it. That is a terrible circle. That is a slightly better circle. And you said, well, we should have came up with all our sides are 12 because it's an equilateral triangle. And you said you got the height, correct? Of that triangle, because you said you got the area of the triangle, correct?
Yeah.
So we can get the area of the triangle pretty easily. Either we use the fact that it's 6, 12, and this would be my h, so we could do 8 squared plus h squared equals, 6 squared plus h squared equals 12 squared. Or we could use the fact that this is 60 degrees. This is 30, so we could use the 30, 60, 90, but you should have came up with h equaling 6 squared of 3, correct?
Yeah.
And then you said the area of that triangle was half of base, which would be 12, times 6 times square root of 3. So you should have came up with 36 square root of 3 for the area of the triangle. And that's about where we're at. Okay.
Yeah.
We should know, right, it's triangle minus circle. So I just need to find the area of that circle. The way to find the area of the circle is I need to have a radius. The best way to draw a radius every single time is to draw from the center to both shapes. And what I mean by that is, so let's do this in red. I would start in the center of a circle, and I'd look at where both shapes intersect. So it'd be about there. It would be about here, and it would be about here. All right, now our goal is to actually turn this into a triangle I can find information about. So just going off kind of gut instinct of making a triangle, I'm going to look at this shape right here. Because that shape right there has a radius, it's got a radius, and I actually know what the measure of this angle is. Because this is going to be 120, because it's 120, 120, 120. So that means I know that this is, let's see, I made this a little small, but this is going to be 120, this is 120, this is 120 as well. So I'm looking at a triangle Where if I cut in half would be a 60, 30, 90. So I'm going to do that down there, and then we'll go from there. This is a good triangle because it's a 60, 30, 90 that I'm going to eventually have. So I got this. I use the blue line to connect. Then we would drop an altitude. And then this would be 60 degrees because it'd be that 120 and a half. This would be a 60, 30, 90, where the red section is my radius. Well, here's the thing. Even though it's a 60, 30, 90, I do need to know one of the sides. I need to know at least one of the sides to get the other two. What are you doing, Sangha? You charging your calculator? Okay, there's a plug right behind you. I need one of these sides. There is a side we can get. And let me back up just a little bit on... Let's talk a little bit about equilateral triangles. It's something we did a long time ago. We proved one day that if you would connect all of the midpoints of an equilateral triangle, you create 4 smaller equilateral triangles. Every one of these 4 is an equilateral triangle. Well, if I look up at what I just drew up here, see this blue dashed line? That's part of an equilateral triangle because of what I drew down here. Since it's an equilateral triangle, if I know one of the measures, I know all of them. Well, this is a midpoint. So that'd make this 6. Not only that, that would make this one 6 as well because that's a midpoint. Well, we have 6. We have 6, which would make the blue line 6. So that is also length 6. So I can come down here and say, well, that total length is 6, but that would be 3 and 3. Well, now I have a 30, 60, 90 triangle where I know one of the sides. Is that far enough, you think, for you to get the radius?
Yeah.
You sure? Or do you want me to keep going?
Yeah, I got it.
You got it? All right, and then that's enough to find the area, right? Because it's just pi r squared. Does anyone need me to go further on that one, or does that good? Good for Sangha. Does all that kind of make sense, though?
Yeah.
Okay, good.
You just use cosine, right?
I would use the 30, 60, 90.
Oh, yeah.
I would use the 30, 60, 90.
Good.
So you're actually going to have 2 squared to 3. Your r should equal 2 squared to 3. Because this would be s squared of 3 equals 3. We divide both sides by square root of 3, multiply top and bottom by square root of 3, and you end up with just square root of 3 for s. And this would be 2 square root of 3s. And that would be your radius. All right, other questions? Sangha. That was emphatic. Number 12. Do you have a specific question or just want to see it?
I just want to see it.
All right. 12 also has just one key that you need to know to solve the whole thing. We have a triangle inside of a circle, correct? And the big thing about that triangle is it is isosceles and it's 90 degrees. So since it's isosceles, let's go ahead and do this. Since it's isosceles, it does say it's got sides of 8, right? Somewhere in there it says 8. So that's 8 and 8. So big picture-wise, I need to do circle minus... We're doing all the shaded area, right? All the stuff outside the circle. All right, so we're going to do circle minus triangle, right? So area of the triangle isn't too hard, is it?
Yeah.
It's not. It's just, so area of our triangle equals not 8 times 8, but it'd be half 8 times 8, which would equal 36.
32.
32, yeah.
Yeah.
It's too early. All right. Here's what you need to recognize. See how this says is 90 degrees? This is an inscribed angle. Yeah.
So would that make the last length the diameter?
That would make this length the diameter. Because this is 90 and it's inscribed, it makes this entire measure 180 degrees. Well, any line that cuts a circle into 180 degrees is your diameter. So this length right here is your diameter. It goes through the center of the circle. And that's not going to be a hard length to find because it's just 8 squared plus 8 squared equals d squared. And then you have to find your r value, which is just d divided by 2. Yeah.
On the answer key, for the diameter, you put 128 squared, or not squared, rooted.
Uh-huh.
And then, but I simplified that.
Yeah. Why didn't I simplify? Is that probably your question?
That's like part of my question. Yeah,
Okay.
why didn't you simplify it?
I didn't simplify it because I knew what I needed to do with it. I knew I had to do more work with it. So in my mind, I'm like, why am I going to take the time to simplify it if it's not my final answer? So what I did is I left it as square root of 128. Because I knew, you know what, I'm doing pi r squared. I'm going to square it anyway.
Right.
So I ended up just squaring it and being able to put it in my calculator and come up with 32 pi. So I didn't want to double simplify something. I didn't want to simplify something that I was going to plug in my calculator anyway.
Alright.
What do you mean?
Yeah, I got 36 pi, I think.
Is it supposed to be 36 pi?
Yeah, because when I simplified it, I
Hang
had,
on, let me check what we got here.
unless I did something wrong with my radius.
So it'd be 128 divided by 4. Nope, it's 32.
It's the radius.
It is 32.
If I did simplify it, it would be if.
What'd you simplify it to?
6 radical 2.
You couldn't do that because 36 doesn't go into 128.
Oh. Okay.
64 goes into it. So you could do 8 times, but you couldn't have had a 6. So you simplified something wrong.
Alright.
Because that means you put 36 into it. 36 doesn't go into it evenly. All right, but our end answer is 32 pi minus 32 centimeters squared.
Yeah.
All right, so the big thing, Sung always recognized that as a diameter. Yeah. Unsolvable if you didn't. All right, other questions? Yeah, Libby.
10. I just had a question about finding the square. On the answer key, I'm pretty sure you did it like the rhombus. You found
I treated it as a rhombus, yes,
How come?
because it's a rhombus. All squares are rhombuses. All squares are rhombuses and rectangles. So you can use length times width, or you can use the rhombus rule. The rhombus rule made it a lot easier because I didn't need to find those missing sides then.
Okay.
So we can always use the rhombus formula. It's diagonal 1 times diagonal 2 divided by 2. All right, let us go into today. Today is kind of review. Realistically, we weren't supposed to go over the sector formulas, but we did, area sector formulas, because I think they go hand in hand with the arc lengths. So all we're doing is we're really reconfirming our arc length and our sector formulas. So the first two are, if I gave you a circle, and I said find the area and the circumference of that circle. All you do for the area of the circle is you say, well, Mr. Pabian, the area is just pi r squared. And then you'd say, well, Mr. Pabian, the circumference equals 2 pi r. And we go about our day. Well, then I would increase the difficulty. I would say, you know what? I don't want that whole circle. I now want just this shaded region here. That's all I want. I want this shaded region here. Well, that shaded region, that is called a sector. So if I need to find that area of the sector, I'm still dealing with the area formula. So let's go area equals. And I would still have pi r squared, but I want just part of that pi r squared. And that part I want, that percent, is dictated by this a value. That will be the degree measure. In fact, I'm going to put a degrees right here so we know it's a degree measure. So we're going to say, okay, well, if I know that a value, we would say the degree measure of a divided by 360 is how much of the circle I want. So it would just be degree over 360 times pi r squared. Well, the circumference is going to deal with the same idea. We just want part of our total circumference. So we're still going to use that 2 pi r, but this time we're going to multiply it by that a degrees divided by 360. And we would then have that little part. So this is entire circle. This is part. This is your sector length, or your arc length and your sector area. All right. Example down here. Once again, I'm going to start with find the area of the circle and find the circumference of the circle. Can someone tell me the area of this circle, the entire circle? Sangha. It's 360? What'd you say?
360.
Not the degrees, area.
Oh, area.
Labib?
196 pi.
196 pi. Let's see. So our area would equal pi r squared. Our r is 14 squared, and you're saying it's 196 pi? You're not saying it's 360? All right, so we have 196 pi for our total area. What's my total circumference? What's my total circumference?
20.
Not you, someone new. Yeah.
Well, it would be 2 pi r, but then it
Yep.
would be 28.
Yep. Perfect. Sorry. Equals 28 pi. All right, what would the area of the small sector be? Small sector means it's going to be the smaller, the shaded in section right here. What would that area be? The area of that small sector, round to the nearest tenth. 65.3. Let's check it out. So we'd have area equals, we're still going to use the pi r squared. We would then use, note that central angle is 120. So our arc degrees would be 120. So we'd go 120 over 360. And Jacob, you said once again 65.3. Did everyone get 65.3? You get something different?
No.
Oh, yeah. Oh, what's the next one, EJ?
Okay, wait, so it says, the, it's 90, yeah, sorry, no, it's 9.3 pi.
This one's 9.3 pi. Let's check it. So we're going, the arc of FE is going to still equal that 2 pi r. But this time we're dealing with 120 degrees out of the 360. And you said it's 9.3 pi? Is that what you said?
Yeah.
Do we agree? That's kind of what I remember. All right, the next one says find the area of the large sector. So the small sector is going to be the quickest way, F to E. It's kind of like when you label two arcs. So my big arc is going to be F to G to E. So that would be our big area. Songha, what'd you get?
130 pi.
You got 130 pi?
You just have to have 130.6 pi.
Oh.
That's fine.
130.6 pi. Yes, so this would be 130.6 pi. Let's talk about two ways to do this. First way, total minus small equals big. I don't know. I'm going off with what he said.
It's
Because you're
0.7.
6'6",
I'm going off what he said. I was going to do that.
well, would you not round to 7?
I would round to 7.
Look. There's a problem. There's a problem.
There was
So
no-
0.999 equals 1, right? So I use like 1 over 3. So 2 over 3 equals the...
Equals 0.66666.
Yeah, so I just... No.
Which is-
Oh.
Which rounds up to 0.7.
But all you have to do is 196 minus 5.
Yes, absolutely. Yes. So, Emma.
Are we not allowed to? Would it be easier to just keep them in fractions if it's because that's like a more exact?
Yeah.
Is it okay?
Yeah, absolutely. So the question was, is it okay to leave as a fraction? I'd say absolutely, because it's a lot easier to subtract and do stuff with. All right. One way is to do that 196 pi minus 65.3. The other way we could have done it is we could have said, well, hey, if that arc is 120 degrees, that would make this 240 degrees, which means I could have also done 240 divided by 360 times our pi r squared. And we would also came out with 130.7. All right, what's the arc length of the large sector? Someone that hasn't said anything. Someone new. They hadn't given me an answer. Asha. 18.7 pi. And that would be that arc FGE. So if we're going to write that out, we go FGE equals 18.7. All right, cool. So that is sectors. Bless you. That is such a weird...
No, because I sneezed and then she was like, oh, it's so loud. And so
No, because it was like a projectile. It was disgusting.
it was not.
She's
I am
lying.
Yeah, that's me.
I did a vampire sneeze.
No.
Okay, why are we talking about sneezing?
Yeah.
Anywho,
Yeah.
let's talk about a segment of a circle because that's something new. Segment of a circle. So we have sector of a circle. Sector of the circle is this entire pi wedge being cut out. Sector of the circle is kind of like that little crust. It's not quite your crust, but it's this little section right here. So your segment, when I say segment of a circle, you're just talking about that little area right there, and yours is shaded in. Mine quite isn't, but there we go. Someone give me an idea of what you think you should do to calculate this based upon what we learned and what we know. How could I do it? I don't need formulas. I just need to know kind of holistically what we would do. Isabella.
Find the area of the whole shape and then subtract
The triangle. Yeah, the whole shape or the sector. So we're going to find the area of this whole thing. And watch this. When I subtract out the triangle, boom, I'm left with just that. So it's going to be our whole sector minus triangle. So it'll be sector minus triangle. So sector area minus triangle area. Well, remember the area of a sector is x degrees divided by 360 times the area formula, which is pi r squared. Our area formula for our triangle is half of base times height. So those are two things we know how to calculate. So let's look at our first example. It says find the area of the shaded region. So we need sector minus triangle. It has to be in that order. You can't do triangle minus sector because your sector is your big minus your small. So let's do our area of our sector first. So sector, what am I right after that area? I have area equals what? Isaac, what am I going to do next? 20. Oh, that's what it's going to equal. Yeah, but what would I? How do I find that? What would the formula be? That's what I'm asking for. It would be pi r squared, but we need something in front of that pi r squared. So pi r squared would be pi times 10 squared. Sangha, what do I need in front of that?
You're gonna need 90 over 360.
I'm going to need 90 over 360 degrees. And that comes from, well, since our central angle is 90, that's going to make this measure 90 degrees. We have 90 divided by 360 equals pi r squared. And that total area is going to equal what? Oh, actually, Isaac already told us that. It's 25 pi. All right, now we need the triangle. Triangle area, well, that's not so bad. It's just half base times height. We have a base of 10, a height of 10. That is half of base times height, which is half of 10 times 10, which equals 50. All right, so that means our segment area is going to equal our sector, 25 pi, minus 50, which you can't simplify any further than that. So it's just going to be 25 pi minus 50. Yes?
Does the 25 pi have to come first?
It has to come first. And that's because that is your area of your sector. It is the biggest. If you type in 25 pi in your calculator, minus 50, it's going to come out as a positive number. If you flip the two, you're going to come out with a negative number. So you'd be subtracting the triangle. You're going to basically go triangle minus a bigger area. Siler, did you?
Yeah, I was just wondering if you could simplify the fraction, 90 over 360, or does that just not work?
The 90 over 360?
Yes.
Yeah.
Yeah. Oh, if you just typed in 1/4 instead of typed in 90 over 360?
Yeah.
Yeah, that'll work.
Okay.
Yeah, just make sure you're not reducing, because a lot of this we're going to plug in our calculator.
Yeah.
So don't spend your whole time thinking about how a fraction reduces. Yeah, but that's 1/4. I mean, yeah. All right, we good on that? Okay, then let's talk about an annulus. An annulus is the region between concentric circles. So we have a big circle and we got a small circle. And I want what's that area between those two. What am I going to do big picture-wise? What am I going to do to solve this, Isaac?
Find the area of the big circle minus the area of the small circle.
Perfect, that's it. Big circle area. Big circle area minus small circle area. Well, in this case, our big circle area in this exact example would be pi r sub 1 squared. And we subtract away the small one, which would be pi r sub 2 squared. Alex, this will also, it matters which direction you put it in. Because you can't do small versus, otherwise you come up with a negative. It'd be the same answer, just one negative and one's positive.
So if it comes to negative, so this
If it comes out to negative, you know you subtracted it the wrong way, so you need to switch it. Yes. Yep. This one's pretty easy to recognize which one's bigger, because you're going to have to put your biggest radius in first and your smaller one second. It's always going to be bigger radius, smaller radius. All right, so our first example says two concentric circles form an annulus. If the radius of the larger circle, I'm going to circle that and highlight that. So we have larger circle, so that is our larger circle. And the radius of the smaller circle is that, what is the area of the annulus? So the annulus is that area between those two circles. I'm going to go ahead and draw this. I didn't ask you to, so on a test, if I don't ask you to draw something, you don't have to, but in this case I'm going to, because why not? So we have something that looks kind of like this, where we have the big circle has a radius of 20, so that'd be 20 there. And the small one has a radius of 13. So that's how you draw your two radii. You draw your long one, make sure it goes to the outside circle. Make sure this one goes to your inside circle. All right, it's big circle area minus small circle area. So big minus small. Our big one's going to be pi times 20 squared. And we're going to subtract our small one, which is pi times 13 squared. Note, you can actually do this subtraction. You can do this subtraction. So you're going to basically do 20 squared minus 13 squared. And what's that going to come out to? Sangha?
231 pi.
231 pi. Perfect. Yeah, John.
Isn't pi minus pi 0?
It would be if it was just pi minus pi, it would be 0. So pi minus pi does equal 0, just like x minus x equals 0. However, keeping this example alive, if I ever did 3x minus 2x, you'd say that equals 1x. Same thing with pi. If I would go 3 pi minus 2 pi, we'd be left with 1 pi or just pi.
Oh, so if it wasn't multiplied,
Yes. So what I'm basically saying is I have 3 objects, and I'm subtracting 2 of the same object away. So I have 3 pies in my hand, and I take 2 of them away, I still have 1 pi left. Yep. Big pi, small pi. Yes. Okay, our next one's a little more difficult. It says the shaded partial annulus has the area 42 pi centimeters squared. If the radius of the larger circle is 16 centimeters and the radius of the smaller circle is 12 centimeters, then what is the measure of the arc? By measure, I'm looking for, I'll specify this like on the test, but I'm looking for the degree measure in this case. I'm just looking for the degree measure. All right, well, they don't give us any degrees, so we really can't use a partial area formula or anything like that. So what I'm going to do is I'm just going to find the area of the entire annulus. I'm going to go, that's all I know how to do right now. Let's go ahead and do that. So we're going to find the whole annulus. So that's our whole annulus is going to be big circle minus small circle. Our big one is 16 centimeters radius. So that'd be pi times 16 squared minus pi times 12 squared. What is the radius, or I'm sorry, what's the annulus of the entire circle? What is the area of the entire annulus? EJ? 112 pi, right? 112 pi. Centimeters squared. Yes. I'll put that on there. Here is the big thing. If I know part of something, if I know part of a whole, it forms a ratio. It forms a ratio between both things. So I can figure out how much of this annulus is taking up out of the total circle. So this is our total circle's annulus. This is our partial annulus. So coming up with that ratio, I'm going to be able to tell basically what percent of the circle I'm talking about. So we're going to use a ratio. And what I'm going to do is I'm going to use small over big. So that means I'm going to use that part. Our partial area was 42 pi over 112 pi. That equals 3 over 8, correct? Correct me if I'm probably. All right, so our ratio is 3/8. In other words, this is 3/8 of my circle. 3/8 of my circle is dictated by this 42 pi. Well, if I know that's 3/8 of our circle, and I know how many degrees are in a circle, Sangha?
So you can divide 360 by 8 and times 3, then you're going to get the angle.
You would. Or we can multiply this entire thing by 360. Sure. It is the same thing. It's the exact same thing. I want to make sure I did everything right. That should come out to 120. No, 135. 135. That's why everything looked weird. All right, 135 degrees would be that. So we use this ratio to tell us that's how much the circle we're talking about. Did you have a question?
So 112 pi is only that like outer.
It would be just the outer edge. So let me fill that in. So I'm saying I want all of this. And then if I take the part divided by the whole, yeah, because we can't find just the whole area because that's not going to make sense. I'm going to focus on exactly what they started off with. Just give me a second.
Yes.
All right. Other questions, because that's a good question. That's your answer, 135 degrees.
When it says measure of arc, you have to do in degrees.
I'm going to specify its degree. Measure is a very subjective term because measure could be,
The length.
it could be a length. It could say find the measure of the length of the arc.
So the test you're going to say length.
I'll most likely say length or something. And if you're ever confused in the test what I'm asking for,
Okay.
you just do that and say, are you looking for the length or are you looking for the degree? All right. Other questions? All right, then the rest of the time is